So thank you, Sassy, and thanks very much for the invitation. The last time I was here at a workshop, I was presenting on TB, and all this was happening around us because it was 2020, right?
Yes.
Yes. So I'm going to give a different perspective. So I run a research institute that's at a university. We have very strong collaborative links with a range of qualified diagnostic labs of very high quality. And we have collaborative links with clinicians and clinician researchers at various hospitals. We also have very strong links to the government public health units, particularly in our state, but also federally. And we also have strong collaborative links with industry. And so what I think we did reasonably well from the laboratory point of view was try to work out where we could make the biggest contribution. And as we've just heard, PC3 labs are not very frequent in most jurisdictions, and we had one of only 2 or 3 PC3 labs within the Sydney Basin in New South Wales, which Sydney is one of the largest cities in Australia, and New South Wales is the most populous state and is where the epidemic started, or actually the epidemic started in Victoria. So it was really how we could work with through those collaborative links that we have to make the biggest difference. And so what we asked ourselves was what was critical against what would be nice to do and where we could make the biggest difference. And so we consulted very rapidly with other research laboratories and the public health laboratories and the diagnostic laboratories to work out what they were doing and what they couldn't do. And I also, there was also other things that Kirby was being asked to do in terms of rollout of point-of-care testing in isolated Aboriginal and Torres Strait Islander communities. And so I wanted to be able to provide laboratory support for that. And so we consulted with the central coordinators of the public health response in New South Wales and federally, and we asked ourselves, is what we're doing duplicative? Is it supplementary? Is it unique? And we asked ourselves what resources we had available, both in terms of the physical laboratory infrastructure, and as I said, we were lucky in that we have a large state-of-the-art PC3 laboratory that was actually being used for blood-borne virus work, not for respiratory pathogen work. So we needed to change how we worked in that laboratory. The capacity to work with respiratory pathogens was there, but we had no real experience of doing that. So along with the infrastructure, just as important as the infrastructure is the personnel, who is able to work in that environment, what is their expertise, what is their capacity, and how interested are they in doing the work? And then how are you going to fund this? What funding did I have that was discretionary that I could move around and point to this? What could I repurpose? And what funding was on offer from the state and federal governments or from my institution, the university? And then how adaptable were these things? How agile could we be? And how fast could we make these resources available? So we developed, I think when you're faced with this, how I sort of tried to approach this was to develop a strategy based on capacity, expertise, and perceived need, to ask very carefully what we were going to do and what we weren't going to do. And then once we decided what we were going to do or had a priority list, try and prioritize that list of what we were going to do as what was the most important thing to do. And that was really where could we make the biggest impact. And then could we redeploy, did we really have the resources to do that and actually make it happen and make it happen in a timely fashion? And also then decide what happens to your business as usual or your core remit. So what happens to the work that you were doing in the laboratory that needs to move aside to take on this whole new gamut of work, and how are you going to manage that? So what did we do? So actually, at this time of the year in 2020, I was talking to a lot of people, and we thought that passive immunotherapies were something that could possibly be developed very relatively rapidly, and I think that came to be true. And the Australian company CSL makes immunoglobulins, intravenous immunoglobulins. They have large plasma synthesis facilities as well as pilot facilities to trial new things, and they were keen to collaborate. We also had at sister institutions associated with the university great expertise in the building of domain-based monoclonal antibodies. So we decided that one of the things we were going to concentrate on was developing a therapy based around passive immunotherapy. We also have a lot of experience in making siRNAs to knock down HIV, which we're developing therapeutically, and we wanted to we thought that we could start to work on that as a potential way of getting to therapy fast. We were wrong on that, but we're still working on that. It's working, but it's not fast, let's put it that way. And as I said, we had been asked by the federal government to look at point-of-care testing using the Expert platform in remote Aboriginal and Torres Strait Islander communities. And we wanted to make sure, we wanted to help with the QA, QC of that, but also to demonstrate that that could be done safely by healthcare, relatively non-laboratory trained healthcare workers, and show that in fact the virus could be inactivated and wasn't going to pose a risk to the people doing those tests in those remote areas, and then also provide training in that. So we needed the ability to grow the virus, both to assess the efficacy of any immunoglobulin or monoclonal we made, but also to demonstrate that inactivation procedures were applicable, but they could also then provide the basis for drug screening as well, and for screening our siRNAs. So we decided to really concentrate on being able to grow live virus and to be able to make highly reproducible assays to look at the effect of therapies on those virus. And one of the things we'd learned from HIV, in the early days of HIV was grown in monkey cells, and it adapted to those monkey cells and really had no great relevance when you were developing a vaccine as a target. And so that held back the initial progress in developing HIV vaccines for probably a decade, until people realised that. And so we were determined we weren't going to make that mistake with SARS-CoV-2, and everybody else, or almost everybody else, was growing SARS-CoV-2 in Vero E6s, which is a macaque cell, and I didn't want the virus adapting to that and us going down a false pathway. And so we decided very early on that we would design human cells, genetically engineered cells that would be adaptable, would be susceptible to SARS-CoV-2 infection, that were reproducible, and that we could then use as the basis for our viral outgrowth and neutralization assays. So what did we decide not to do? We decided we weren't going to develop a vaccine because there were so many other people doing that, and particularly the commercial companies were already months ahead because a lot of them had been already developing vaccines for MERS and other coronaviruses. So we thought we'd always be playing catch up there. We weren't going to rely on a pseudotype assay for viral knockdown. We developed that in parallel as a validation exercise, but we wanted a live virus. We weren't going to offer a diagnostic service because the diagnostic labs that we worked with were going to do that, and we didn't want to compete with them. But we could offer, the neutralization assays to complement their standard serology. So we worked directly with them where they did the serology and we did the neutralizing antibodies for them. And we weren't going to genetically engineer a live virus because the approval process for that in Australia, we'd probably still be waiting for the approval. So we'd never get the work done. So we were going to use primary isolates. So why was this important? Well, I felt as a clinician that passive immunotherapies would potentially provide a rapid pathway to regulatory approval, so we would have early therapy. As I said, we had a very strong industry partner to make the hyperimmune globulin. We had collaborative partners that could make monoclonals, and we had, the Kirby has great experience in the conduct of early phase and late phase clinical trials. And also that approach serves the at-risk population, so even if there was a vaccine, passive immunotherapy would still be important in people who were immunocompromised. So I had some discretionary funding which I decided to use, and we were lucky that the university also supported us with some seed funding, and then we managed to get peer-reviewed funding. We had expertise in the lab, particularly under the leadership of Stuart Turville, who is a fantastic virologist who really led this. And so what did we need to make this happen? Well, as I said, this was a blood-borne virus, PC3 lab. We needed completely new PPE. We needed the respirators. We needed to learn how to use those. We needed to train our staff how to use those, how to maintain those, how to look after them. We needed some new equipment, and we needed new standard operating procedures, as well as new safe work practices, all of which needed to be developed rapidly. We needed cooperation of our collaborative partners. We needed to communicate with them what we were doing. We needed to assemble cohorts as sources of plasma and sources of virus. We needed the various regulatory documents, the collaborative research agreements, the confidentiality agreements, the material transfer agreements, and we needed safety approval from our institution. And I have to say that the university is usually very bureaucratic and very, very slow, but in this case they decided this was an emergency and they pulled out all stops and they worked very strongly with us, unlike a lot of other universities in Australia. So we got ahead very quickly. So I've been through a lot of this. We had to, we bought extra biosafety hoods and installed them in the PC3 lab. We got all the specialized PPE and learned how to use it. We worked in partnership with the diagnostic services. We developed a neutralization assay working with New South Wales Health Pathology and got that accredited by our regulatory board within 6 months of the epidemic starting, which normally to get a new assay approved by the Therapeutic Goods Authority in Australia would take you 2 to 3 years. And so we did that in record time. And then we started screening for the equivalent of the Red Cross here, called Lifeblood in Australia. We started screening plasma donations for neutralization activity and working with CSL in developing and screening batches of hyperimmune globulin. And we developed a suite of assays and tools to detect neutralization using human cells. The training was very important. We couldn't risk having virus escape from the lab because at that stage Australia was undertaking a sort of a COVID zero approach, and so there was very little virus in 2020 circulating in the community. So if any virus if any of the lab members had got infected and transferred the virus out of the laboratory, that would have been, we would have been closed down in minutes. So, it was very important that we did everything very properly. And so the training of the staff, getting them all the right PPE, consulting with the experts, sharing our knowledge with the knowledge of other people that are running PC3 labs, was very important in getting this going. So because the university told people that weren't working on COVID they weren't welcome on campus most of this time, it wasn't very difficult to decide to turn the lab over to this, because unless you were working on COVID, you weren't allowed on the university campus. And the Kirby, a lot of the work we do is in the context of clinical trials and cohorts. And at that stage, the instructions from the international bodies that govern ethics and that sort of thing was that unless clinical trials were life-saving, they should be put into hibernation, which is what we did as an institution. So a lot of our work dried up anyway, so we had a group of people that we could reallocate. We didn't get everything right, and we rapidly realised the importance of genotyping the virus as well as phenotyping the virus, and some of the genotyping that was being done in New South Wales was pretty clunky and slow at the time. And so, again, through a collaborative approach, working with experts in AI, we used novel ways of genotyping the virus, rapidly genotyping the virus, reducing the turnaround time from several days to 24 hours. Communicate. You need to bring everybody along with this. Communication is really important. Talking to your local staff, making sure they understand what the strategy and plan is really, really important. Making sure that they're well trained and feel safe, and make sure they understand the SOPs. You need to bring your institution along, and again, that's about communication. And then you need to bring along all your collaborators, some of which are listed there, and again, that's about communication. And so you do a lot of talking to a lot of people if you want to keep everybody on board all the time. And I'll leave it there.